Hello, so today we are going to be looking at primitive types in Rust. I've gone ahead and created a cargo project for this video. You can go ahead and do that. If you don't know how to do that, you can watch the getting started video. So the first type we're going to be looking about is the bool. So let's create a variable that contains this. So booleans are named bool in Rust, and we can annotate the type using bool. Booleans basically means true or false, or I used to express true or false. The true is with small letter, true or false. So Booleans are used to express true or false, and we use them mostly in conditionals, as conditionals for like if statement or for flow control. You can also use them to keep a loop running or to break out of a loop. So the next type we're going to be looking at is the character type. So the character type is a type that holds a single Unicode character, a single standard Unicode character. This can be an alphabet or a symbol. So let's create a variable named x. So if we create this, we are going to see that it is usually declared in single quotes, not double, single quotes, and it can hold single Unicode values like alphabets, and it can even hold symbols and emojis, since emoji is a valid Unicode character. So the size of characters are usually 4 bits and not 1 bit like other language. So the next type we're going to be talking about is the integer type. Integer type are mainly of two types, that is an unsigned and a signed. So an unsigned integer contains only positive numbers, while a signed integers contain negative and positive numbers. Unsigned are represented using a U, while signed are represented using an I, followed by the bit size. So let's create a variable with an unsigned 8-bit. So this unsigned 8-bit can contain values from 0 to 225. Anything above this, it's going to overflow and you're going to generate a warning error during compile time by your compiler. To, for example, create a signed integer, it can only contain numbers from 0 to 127 and from 0 to -128. This is because it follows 2 and this shares space. You cannot go above -128 and go above 127. So integer type are usually of 8-bit, 16-bit, 32-bit, and 64-bit. So basically, these are the sizes of integer types. So now this leads us to another category or another type of integers, and these are not fixed numbers. The ones we looked before have fixed byte size, but this number is what we call variable size and is dependent on the architecture of the system. So it's usually represented using U size, that is for unsigned variable size, or I size for signed variable size. It can hold maximum number up to the amount that the systems can tolerate or can accommodate. So if you're using a 64-bit system, it can hold up to 64 bits. But if you're using a 32-bit system, it's going to hold up to 32 bits. So the next types we are going to be looking about are floats. So floats are used to represent single and double precision numbers, or what we know as decimals. So floats are usually represented using float is usually represented as in F32 or F64 bit. So the F32 bits contain 32-bit float and F64 64-bit float. So we can create or annotate the type using F32 and then we put the number. Or we can also use the 64-bit for this same operation. So we are going to look at other data types known as array. Array is a list type data structure. It is usually found in many programming languages like as lists in Python or arrays in JavaScript. But for Rust, arrays are of fixed length and can only contain the same data type. So let's create an array. So array is represented like this. We are going to put the data type it contains. So specify the data type it's going to contain. For now, assign 32-bit, a semicolon, not a comma, a semicolon, and then the number of elements it's going to hold. And then we are going to represent the elements. Remember to add a semicolon at the end of the declaration. So this is the definition of an array, and you're going to put the type and the number of elements that the array is going to contain. So by default, arrays are immutable and can be mutated using the mute keyword, and can be made mutable using the mute keyword. So we can also initialize an empty array, or let's say initialize an array with default value. So let's make it an unsigned 64 bits and 5 characters. To initialize it with default values, what we have to do is just to put the default value, then semicolon, and then the number of elements, that is 5. So let's print this out to the command line. So how we are going to format for the printing, that is the text interpolation for arrays, is kind of different from how we did with normal data types. So we are going to put column and a comma and a question mark. So let's run our array. So we run it with cargo run, and we are going to see that it has created 5 elements with default value of 19. Ignore the warning at the top. This is because we did shadowing. That means we changed the type and the value without changing the variable name by declaring it again. You can watch my previous video on variables for more about shadowing. So how do we access our elements in array? Elements in array are accessed by using the subscript notation. So for example, let's try to print an element or an item in the array to the command line. So let's try to print the first item in the command line. In array, the numbering starts, or the index, the numbering starts from 0. So if we want to print the first element, it's going to be 0. The second element is 1, and so on. So if we want to print the first element, the 0 index, we are going to put a subscript notation and then the index of that element. Since it's the first element, the index is going to be 0. Let's run this using cargo run. And we are going to see that 5 is printed out, which is the first element in the array. Let's also try to print out the third element in the array by putting an index of 2. We can get the length of an array using the .len function, and this prints out the length of the array. So let's run this using cargo run. We are going to see that the length of the array is printed out, which is 5, because there are 5 elements in the array. So that's all about arrays. Now we are going to be looking at tuples. And tuple is also a list type data structure, just like array. It is created using parentheses surrounded with values separated by comma. But the difference between tuples and arrays is that tuples can contain different data types. So we use parentheses, specify the types that are going to be in the tuple. Let's create a signed 32-bit and a string slice. Tuples is an ordered list type, and it is surrounded by parentheses, and its values are separated by commas, just like array. The main key difference is that tuples contain different data types. So we can access the elements in tuple just like array by using dot notation. In array we use subscript notation, but in tuple we access the elements using dot notation. So you put dot and then the index of the item or element you intend to access. So here we put .1, so we can access the second element. We try to print this to our command line. Now let's run this. We are going to get hello, which is the second element in the tuple. That's how elements are accessed in tuples. So in tuples, we can also use what is called destructuring. So destructuring allows us to create variables using the values in the tuple. Let's use the let destructuring. So we just put the name of the variables according to the position we would like those values to be assigned to. So for example, we'll use number as the first variable and greeting. So our number is going to contain the value 10 and greeting is going to contain the value hello. And then we'll make it equal to the tuple that we are destructuring. So 30 is going to be number and hello is going to be greeting. So we can access this variable normally like we'll use other variables. Let's try to print this to a command line. Let's print number. So let's try running it. Ignore the one at the top. This one is due to the fact I did not use greeting, even though the variable was created. But we are going to see 30 printed to the command line. And this 30 is the value gotten from that tuple. That's the first item in that tuple. Since tuple is ordered, the variables are going to follow the tuple ordering. So this is going to be all for tuples. So the next data type we are going to be looking at is the slices. So slice is basically a reference into another data structure. Slices are created from existing variable binding. They have a defined length and can be mutable or not mutable. So how are slices created? So let's say, for example, we have an array that contains signed 32 bits, 5 items, 5 elements of signed 32 bits with values of 5, 4, 3, 2, 1. So we can create a slice of this array using the superscript notation, but in the front of slices, one thing about slice, in the front we are going to put an and sign and then the name of the variable that we are creating a slice of its data. So we'll put dot dot. Dot dot means that I should slice the whole thing, that is all the whole values. So let's try to print this to our command line. So we cannot print a slice. Since we are going to be slicing an array, we are going to use the formatting for arrays, not the standard formatting, to print it to the command line. So let's run this using cargo run. And we are going to see that the whole array is going to be displayed to the output. So what if we intend to remove specific digits or specific elements in that array? So if we intend to cut out only 5 and 4, we can use this using 0, that is the first element, the index, and 2. So although 2 is the third in the element, this creates a slice of 5 and 4. It starts from 0 to the element before the end element. So if we run this, we are going to see only 5 and 4 displayed to the terminal. That is because our slice starts at the first index and ends at the value before the index specified. It's going to end before the third element, that is the second index. That is 5 and 4. So slices work with different data types. The next data type we're going to be looking at is the string data type. So in Rust, there are two types of string, a string literal and a string. I say string literal, sorry, I mean string slice. So the difference between these is that a string slice has a fixed length since it's just a reference. And then the string is a heap allocated data type and it has a growable size. So a string slice has a fixed length, but a string does not. So we are going to be looking more about string in upcoming video. But for example, let's try to create a string slice and we're going to put the and sign and then str, and this is going to be equal to a string. So let's call this defate. Or we can create a string. There are two ways of creating string. The representation of string is just string. So we can create a string, converting a string slice to a string using the .toString format. Or we can also use string from and then create it from a string literal, from a string slice. So these are the two types of string, and this will be all for this video. For more about this series, you can check on the playlist and you can also check the previous video to understand more.